Hi, friends and neighbors. I just wanted to give you a little update, refresher about the analyses that we learned about in class. And I decided I'd make a video of me doing some of the analyses so that you can go back and watch it and rewatch it. And if you want to work on any of these analyses at home and maybe redo them, or if you just feel like you got lost in class today and you'd like to see me run these analyses again, I made this video. So this is sort of what your data set should look like. And remember, the way this is set up is you have the names of your variables across the top, and each row represents a different participant. So I made a separate video about how to get your data entered into a spreadsheet, so I'm not going to go over that again right now. What I'm going to focus on is the types of analyses that we learned about in class. So the first thing that I want you to include in your paper is what I call descriptive statistics, which would include those measures of central tendency, so mean, median, and mode. And when you're running those different descriptive statistics like we talked about, you need to think about whether or not they're appropriate for the kind of data that you have. So the first one that we're going to run is to just get a mean, which is really the arithmetic average of all the numbers in that variable. And even though the mean is sort of everybody's favorite, it's only appropriate if you have interval or ratio data. So if you have categorical data here, like what's your gender, and I've just coded a 0 for male and a 1 for female, it wouldn't make sense to get an average of that because those numbers don't actually represent a quantity of something. So if this is my student's GPA, it would make sense to get an average of people's GPA. So let's do that. So when you're working in Excel and when you want to calculate something, you want to start from an empty cell, so one that doesn't have any numbers in it, and click into that. So I'm going to click right here under my GPA column. And anytime you're going to calculate something or write a formula, you have to start with an equal sign. And the equal sign tells Excel that you're going to be entering a formula or running some sort of calculation that you need them to calculate. So equal sign, and if you want to get a mean, you just type in the word average, and Excel kind of does a little autocomplete stuff down here. When you start typing a word that looks like one of its formulas, it makes some suggestions for you. So it is actually this first formula that they suggest right here, but you don't actually have to click on one of those. So you can just type average. And these formulas are also listed out in their complete form on the slides that I posted as well. So average, and then you open parentheses, and it wants you to just highlight the numbers that you want to get an average for. So when we're highlighting things in Excel, you click on the first thing in that set, you click and you keep holding down your clicker and you drag to the bottom of the numbers. When you're getting an average or any kind of calculation, you don't want to highlight the names of the variables because that's not a number and you won't be able to compute anything with that. So highlight the range, close parentheses, hit enter. And this number right here that it spit out is the average GPA in my sample. So on average, students in my sample had a GPA of 2.94. So any kind of variable you have that's interval or ratio, so this is the number of days a week that people exercise, you can get the average for that. So average, don't forget that equal sign, highlight the numbers you want to get the average for, close parentheses, boom. Okay, so that tells me on average people in my study exercise 3 days a week. So get the mean for any variables that it makes sense to get the mean for. You could also get the median if you think that's descriptive. So if you have a variable that is a little bit skewed maybe, like if you have a GPA variable and most people kind of reported being at the top of the GPA range, when you have data that's not normally distributed like that, sometimes a median, which is the middle point, so 50% of people scored above it and 50% scored below it, might be a really interesting thing to report. And the median is something that's really easy to get quickly in Excel. So I'm going to get the median GPA. So what was the middle GPA? And again, start in a new clean cell, equal sign. And for this one, we just type the word median, open parentheses, highlight the numbers you want to get median for, and close and enter. You can get the median for ordinal data. So if you have a variable where you put people, you had people select an option, so how many hours a week do you work, and you had one option being like 0 to 8, and then the next one was 9 to 14, and so like the order of those categories is meaningful, but the number is just sort of assigned to it like a category. Getting the median for a variable like that might be really interesting. So I'm going to get the median here, median, how they rated their relationship. And so this, yeah, it looks like people's relationship ratings were a little skewed because on a scale from 1 to 5, 50% of people rated their relationship out of 4 and above, which is pretty high. So that's how you would get the median. If you have categorical data, so that would be something where the numbers don't indicate a quantity of anything and the order of the numbers is not important. So if you have people rate what their major is or somebody's gender, that's going to be a categorical data. And you might want to get the mode for that, and the mode would be the most frequent response. So when you're getting the mode, or like whether or not somebody lives on or off campus, to get the mode, you type an equal sign in a blank cell, and the formula is a little bit more complicated. You type mode dot SNGL, like I just want the one most frequent number, open parentheses, highlight the area you want to get, close. And so I know the majority of people in my sample lived on campus. So those are all the measures of central tendency you might want to get. Let's do a little bit of the inferential statistics that you might want to include in your paper. So most of you are probably going to have at least one correlation that you want to run. And remember, a correlation is the degree of linear relatedness between two variables. So if you want to run a correlation, first you need to make sure that the two variables that you want to see if they're related are continuous. So like I mentioned in class, if you have a categorical variable that you've coded as 0 and 1 for gender or living on and off campus, you can actually do a correlation with those variables if you have them coded like this. So when you're going to run a correlation, start over here in a new cell. And just another tip, anytime you're running one of your really important tests for your hypotheses, I kind of like to type a little label next to where I run the test so that I know what that number was talking about. So I'm going to say, okay, I'm going to run a correlation between GPA and exercise. And then I'm going to get in a blank cell over here, and this is where I'm actually going to type the formula to run the correlation. So again, we start with an equal sign, and the formula we use to get a correlation is CORREL, open parentheses. And now instead of just highlighting one thing, you have to highlight two, which makes sense. Like, okay, here's variable number 1, comma, here's where variable number 2 is that I want you to look at. So I said GPA and exercise. So the first thing is I'm going to highlight all the GPA numbers. And you can see how it's kind of colored that variable blue, and it's blue over here in the formula, comma. And now it wants you to highlight what's the second variable. So exercise, how many days a week you exercise. And that one is green. And you can kind of see how the numbers in the formula are mapping it onto where you've highlighted in the spreadsheet, which is handy. Close parentheses, enter. And the number that Excel spits out for you that's actually the Pearson's R. That's the correlation coefficient. Just from eyeballing it, a 0.54 looks like that's a moderate positive correlation. And if you get a negative sign in front of that, that just means you have a negative relationship. It doesn't mean anything about the significance. It just means as one thing goes up, the other thing goes down, which could make total sense for your variables. So what you need to do is interpret this R that you get based on your sample size to see if it's significant. So in this file that I've uploaded on Blackboard, if you look down at the bottom in one of these tabs, I've actually pulled the numbers out of the statistics textbook so that you don't have to do that. So look in this column first and say, okay, how many people filled out your survey? I asked you to do 20. If you have a few more or a few less or a few more than that, I have those numbers up here too. But let's say you had 20 people in your sample. Here's the degrees of freedom that you're going to need to report when you're writing up your statistics. And then the number in this column is, okay, if you had 20 people fill out your survey, if your R is bigger than an absolute value of 0.444, then you have a significant correlation, P less than 0.05. And this counts too if you had like a negative 0.5, because the absolute value of that is still bigger than a 0.44, and that's what you're interested in. So if your R is bigger than whatever the cutoff here is for your sample size, then that means you found a significant relationship. So for 20 people, it needed to be bigger than a 0.444. So let me go back and look at what I found. And so my R that I calculated was a 0.5449, which is definitely bigger than that cutoff. So I would throw a party and say, yay, I had a significant correlation between GPA and exercise. All right, there's just one more type of analysis I want to show you how to do if you need to do an independent samples t-test. So if you have two conditions, like two versions of your survey that you want to see if people who got the different versions scored differently on some kind of outcome measure like anxiety. So does taking a survey on blue versus red paper change your level of anxiety? For that, you're going to first of all make sure that you have some sort of variable in your data set that indexes their condition membership. So condition, and then were they in condition 1 or condition 2, and that's just going to be however you manipulated your variable. So like this would be somebody who saw red paper, this would be somebody who saw blue paper, etc. So you would need to have some kind of condition variable or some other kind of grouping variable if you want to compare people who live on or off campus and see if they differ in their GPA. You would want to use a t-test. So if you're going to run a t-test, the first thing you need to do is highlight all of your data, including, and now this is different, the variable names. Because what we need to do is get your data sorted in order of that variable that you want to make the comparison on. So if you want to compare people who live on and off campus, we're going to sort our data by that variable. So whatever your grouping variable is, the groups that you want to compare. So get all your data highlighted, drag and hold. We're going to go up here to data, and we're going to sort it. And this little box will pop up and you say, I'm going to sort my data by, and then pick the name of the variable that you want to compare. So I want to compare people who live on and off campus. Click that one. You don't need to change anything else, and then click OK. And you can see that it kind of moved my data around, and now it's lined people up so that all the people who lived off campus are first, and then all the people who live on campus are down here. Okay, so now I've got it in order and I'm ready to do a t-test. So I'm going to write my label over here, t-test comparing GPA of people on and off campus. So that's just reminding me later when I save this, hey, what did I actually run a t-test about? Click in a new cell, equal sign, and then you're going to type t.test, open parentheses. Now stick with me, this one is a little bit more complicated. So I'm looking at how people who live on and off campus differ in their GPA. So I'm going to be highlighting the GPA numbers. And the first is, so here's people who live off campus. I'm going to highlight their GPAs, see how it stops right where the zeros stop, so their GPAs, comma. Now I'm going to highlight the GPAs of all the on-campus people and see that just lines up right there with all the ones, which are my on-campus people. So basically I'm saying, like, does this group's stuff look different than this group's stuff? But wait, we're not done. It wants to know some things about the kind of hypothesis you're using. Don't worry too much about it. Just do a comma. I want you to type a 1 and then comma a 2. Okay. Yep. Okay. Close the parentheses and then click enter. Now, the number that Excel spits out when you run a t-test, unfortunately, is not actually the t-value, which is annoying. It actually just spits out the p significance value for you. And you want p to be less than 0.05. So I'm kind of close on this one. which means maybe I have what we would call a marginally significant difference, but you want this number when you're running a t-test that it spits out to be very small. So the closer to 0 this is, the bigger the difference between your two groups. So I had I would call this a marginally significant difference in the GPA of people who live on and off campus. And that's how you run all of the analyses that we learned in class this week. And I will continue to work with you in upcoming classes on how to write all of this up. But this is just like a nice little explainer so that if you're trying to do this on your own or you want to rerun it, you can watch the video.